Now we're on section 4.2. We're going to do question 22. And what we have to do here is show that this function has exactly 1, 0 on this interval, negative infinity to 0. Here's our strategy. We're going to take a derivative, show that it is always has a positive slope or always has a negative slope on this interval. With that done, we're going to evaluate the limits of the endpoint, or the limits of the functions, as x goes to negative infinity and then as x goes to 0, and see if we cross the x-axis any place, if we get opposite signs. If we get opposite signs, then we must have crossed the x-axis someplace and our work is done. So let's find the derivative, and I'm assuming now you don't have any problems finding the derivative. So the derivative of this is 3x squared. The derivative of this term is going to be minus 8 over x cubed, and the derivative of 7 is 0. Now, as we go to negative infinity, when we square it, take any negative number and square it, you get a positive. That term's going to be positive. Take any negative number and raise it to an odd power, and you get a negative times a negative. This term's going to be positive on this interval. So now we're greater than 0 on the interval negative infinity to 0. So that task is completed. Now let's look at the limit as x goes to negative infinity of f of x, and see whether we get a positive or negative value. As x goes to negative infinity, this term, the first term, is going to go to negative infinity. The next term will blow up. In other words, if we square something very negative, this it goes positive, and this denominator is expanding out of control, and so this term is going to 0, and we get a plus 7. And negative infinity plus 7 still goes to negative infinity. The big deal here is, on the left we've got a negative value. Negative. Let's look at what's going on, the limit as x goes to 0 from below of f of x. As x goes to 0 from below, that term is going to go to 0. This term, as x goes to 0, well, keep in mind, let's put in a very small value for x. Consider this. What if we have negative, because it's very small, negative 1 over 10 to the 6 squared? When you square that, isn't that going to be 1 over 10 to the 12th? And isn't that going to be, when you invert and multiply, 4 times 10 to the 12th? Would you agree that number is enormous? And the smaller you get, the larger this gets. So this term's going to infinity, and plus 7. So this is going to ultimately infinity, which is positive. So somewhere in there on this interval, we cross the x-axis because we went from negative to positive. There's our argument. There's exactly 1, 0 for that function. Now we're doing question 43, and we're given the velocity is 9.8 t plus 5. S of 0 is the distance, and that equals 10, and v equals ds dt, or v equals s prime of t. Now if you go to corollary 2, on page 233, that's what we're using to build this, so please refer to that. So we know this, that S prime of t equals 9.8 t plus 5. So therefore S of t equals 4.9 t squared plus 5t plus c, some constant c. So now we're given this piece of information, S of 0 equals 10. Well, S of 0 equals 10, I'll put a 10 here and I'll replace every t with 0. Replacing t with 0 here, that goes to 0. Replacing t with 0 there, that goes to 0. And the only thing that's left is c. So now we know S of t equals 4.9 t squared plus 5t plus 10. And that's what we had to find. We had to find the body's position at time t, and that's the body's position at time t, and we're done. Well, now we're doing question 51, and it took t equals 14 seconds for a mercury thermometer to rise from negative 19 degrees Celsius is less than or equal to the temperature, which is less than or equal to 100 degrees Celsius. It took 14 seconds for that temperature to rise from negative 19 degrees to 100 degrees. And they want us to show that somewhere along the way the mercury was rising at the rate of 8.5 degrees Celsius per second. Well, the range here is, we covered 119 degrees. So let's take 119 degrees Celsius. We covered, it changed, it went up 119 degrees in terms of Celsius, and we'll divide by 14 seconds, and it turns out that that equals 8.5 degrees per second. So we just showed that somewhere along the way the mercury was rising at 8.5 degrees per second. Now, it may not have been all the way, it may have gone slower than faster, but the average was anyhow 8.5 degrees per second. And we're done.